In this video, I'm going to show you how to write the correct trig equation for a given triangle. Trigonometry is made up of three basic functions: sine, cosine, and tangent. And I can remember being in geometry class in high school as a freshman and learning about Chief SOHCAHTOA from my geometry teacher. He was an older man. He was on his way out. He was retiring at the end of the year. So he would tell some colorful stories. One of those stories that he would tell us was about the Indian chief SOHCAHTOA. He probably should have said Native American, but we were in 2002 and people didn't seem to care very much, I guess. He certainly didn't care. But it stuck with me this whole time and keeps me able to remember what sine, cosine, and tangent are. So all he had to do was tell us about the Indian chief SOHCAHTOA. He didn't have to tell us any story about him. He just told us this name. It was so blasphemous that we all remembered the story and the person. So let's take a look at what SOHCAHTOA means. First, you need to know your phonics in order to remember how to spell SOHCAHTOA. So that's already an issue there. But anyway, let's just go over it. Most people are able to remember it. So SOHCAHTOA, S-O-H right here. The S is for sine, and all of these are of an angle theta. And then it equals the opposite over the hypotenuse. And we're talking about sides of a triangle right there. But we'll get into that later. The next one that we have, as SOHCAHTOA goes, is the CAH, which goes with the cosine of some angle theta, and that's equal to the adjacent side over the hypotenuse side. Again, these trig functions are of angles and have relationships between the sides. And then lastly, we have the TOA, which is the tangent of some angle theta, is equal to the opposite over the adjacent sides. And we're going to get into what all of those mean and how to find those in a second as well. The goal for all of these problems is to write an equation that has one unknown. As we've learned in algebra, if we don't have only one unknown, we won't be able to solve it unless we have a system of equations. And I don't think anybody enjoys systems of equations, so we're going to try to avoid that by finding the equation that has one unknown, so we don't have to have multiple equations with multiple unknowns and find them some other way. Let's take a look at our first example. Okay, in this example, we're looking at a capital letter B that's an angle, a lowercase b that's 3, and we're looking to find something that looks like a cent sign. That's bizarre. Let's start by drawing a triangle, and then I'll go over these conventions for you. All right, so we draw a triangle. A lot of times students really want me to draw the square in the corner because it's a right triangle, and to show the right angle there. I'm not going to do that every time. It just doesn't seem that necessary to me. I know that I'm drawing a right triangle. I'm not being graded on my ability to draw a right triangle, and neither are you. All right, so back in geometry, you learned about the Pythagorean theorem that relates the sides, and you were using lowercase letters there for the sides, and we're going to keep that convention going. So we're going to use this as side A and this as side B. As you learned in geometry, you can label them any way that you wanted. You could flip them. So if I wanted, I could move the B to here and move the A to here. Doesn't really matter. And this was always side C. Now I make it into a cent sign because I want to be able to easily differentiate between lowercase c and capital C, and those letters look the same to me. So that's how I've chosen to do that. Now the next convention is super important, and that is that the angle that matches the side, so there's going to be an angle A and an angle B and an angle C, they have to be opposite the sides with the same letter. So I'm going to make capital A over here because it's opposite side A. And if you're having trouble understanding what opposite is, well, this is always the hypotenuse. C is always our hypotenuse. So angle C is always going to be here. No questions asked, right? Now you're wondering, how come B is not opposite, or side B is not opposite angle A? Because it's part of angle A. As you can see, angle A is made up of, we have this ray and this ray make up angle A. See, B and C, they're part of the angle. So they can't be opposite the angle. Something that's part of something can't be opposite of it also. So that's how that, you know that it's opposite. Now we need to label angle B. Angle B is opposite side B, so that puts it right here. And again, if I were to show you what angle B is made up of, it's not made up of side B. It's made up of side A and side C, not B. So that's how we can also find the opposite side that way. All right, now that we have this triangle labeled correctly, this is going to be how we're going to label all of our triangles. But now that we have it labeled correctly, we can now put in the information that we have and look at what we can do with it. So that's angle B right there, and I'm just going to mark angle B so I know where my perspective is. That's how I'm going to be able to make my trig functions. I could make it from angle A, but it's not useful in this case because I don't have it. I could find it pretty easily, but I don't have it. I don't want to do extra work. I'm just going to use the angle they gave me and the side that they gave me also. So this is side B, which is 3. All right. So now I want to identify the relationship between the angle and the sides. The side that I'm solving for is this one right here. That is my hypotenuse. So I already know I'm not going to be using tangent. Now I'm going to look over here. That's opposite. Also, I can know that they're opposite because they have the same letter, but one's capital and one's lowercase. So I have to think what trig function uses opposite and hypotenuse, and that is the sine function. So I get that the sine of the angle, which is 30 degrees, is equal to the opposite over the hypotenuse. And that is my equation. I'm not going to solve that equation, just set it up. In another video, I will show you how to solve these equations. All right, let's go on to the next example. Here we have no triangle. So again, anytime that we're given a description of something, I mean, if we don't have paper, we should picture it in our heads. If we do have paper, we should probably draw a picture. So I'm going to go ahead and label my triangle. All right, it's all labeled as much as I want to label it, and now I'm going to put in the information. So I have this is 7, I have this is 35 degrees, and I'm looking for that guy right there. All right, so the relationship between the angle given and that side that I'm looking for is adjacent, and I know that this C here is always my hypotenuse. So now I have to think what trig function uses adjacent and hypotenuse. That is my cosine function. So cosine of 35, again, always of an angle. You never want to put a fraction in there. If you're doing cosine of some fraction, oh boy, you need to start back over at the second slide that I showed because it's always an angle. So we have the cosine of 35 equals, and we're going to go just to its definition, adjacent over hypotenuse. So that's the B that we're looking for, divided by the 7 that we were given. Again, I'm not going to solve this equation. I'm going to come back through these slides and solve them in a future video. On to the next example. All right, again, start with your picture. And then start with your generic labels. Start with A up here. Again, the only thing that matters is that angle A is opposite side A, and angle B is opposite side B. All right, now I can go through and I can label them with the information I was given, and it'll also help me with my perspective from that angle. All right, and I always circle the thing that I'm looking for. All right, so we know that with respect to this angle here, we have the adjacent. All right, and we also do not have the C, so I'm hoping we have the opposite. Yes, we do. So we're looking for something that uses opposite and adjacent. That would be our tangent function. And the tangent of the angle 40 is equal to the opposite, which is 6, over the adjacent, which is B. Be really careful when you're using the variable B. You might even want to replace it with an X because it looks a lot like a 6. Even specifically in this problem where I have a 6 and I have a B. Oh boy, don't think that that's 1 and think that there's nothing to solve for. Anyway. All right, so you always want to keep in mind 2 things that are really basic about triangles. We always want to use all of the information that we know about something to continue to learn more about it. So there are these two concepts that you learned about in geometry, the Pythagorean theorem that relates all of the sides of a triangle, and the triangle angle sum theorem that relates all the angles of a triangle. The Pythagorean theorem says that if we have sides, legs specifically, A and B, that if we square them and then sum them together, they're equal to the hypotenuse squared. So you can see that we were always using this lowercase ABC convention. No one ever made it into a cent sign. I'm just making it into a cent sign. If you don't like that, don't do it. It's not a big deal. The triangle angle sum theorem just says that the sum of all of the angles of a triangle in Euclidean geometry, which is the only thing that matters to us, is 180 degrees, I'm sorry. So we can write that out as capital letter A plus capital letter B plus capital letter C is equal to 180 degrees. And we only care about degrees right now. Later on we'll get into radians, but not right now. Okay, let's just wanted to keep those things in mind because they can be used in order to make these triangles more complete. Some teachers might ask you to solve a triangle. That means to get all of the information. And with all of these triangles, you have to be given two pieces of information in order to make a triangle. They can't be two angles because the sizes of the triangles would get different. But you could be given two sides. So you could find the third side using your Pythagorean theorem. But anyway. All right, let's take a look at 3 more examples of how to write trig functions or trig equations using trig functions. All right, so in this one we're looking to find capital B. So that's going to be a little bit different. But the setup is exactly the same, and that's what I want to make sure that I'm stressing here, that the process might change a bit depending on what we're looking for, but the setup has to be the same. If it's not the same, things can go really weird. All right, so here's angle A, here's angle B, here's side C. That doesn't look like a C. Much better. All right, then we have, what is this? This is side B and this is side A. All right, now we're going to label the information that we know. All right, so we got, we're finding B, so I'm going to circle that. That's also going to be our perspective because they're talking about that angle. If they talk about the angle, you're almost definitely going to be using it, so that's the perspective. Then we have B, side B is 6. Ooh, B's and 6's again, how fun. And then we have the hypotenuse C, which is 10. All right, so using that angle, that side is opposite, and this is always my hypotenuse. So I have to think what uses opposite and hypotenuse, that is sine. So we get sine of the angle, that's B, is equal to the opposite, which is 6, over the hypotenuse, which is 10. You could simplify that, but again, that's kind of like finding the third side of this triangle. We could do it. It's 8, but we don't care. So why would we do that? I could simplify this to 3/5, but why would I do that? This is what we were trying to do, write the equation. I did that. I'll show you guys how to solve these equations later, but the setup, being consistent, is really good. All right, let's move on to the next example. All right, I think you get the idea at this point. We're going to draw a triangle, and we're going to label the generic triangle. All right, now I'm going to put the information in for this triangle. All right, so we are finding angle A. I'm going to circled that, and I'm going to give me, that's my perspective to look at everything from. We know that my hypotenuse is 10. We know that my side B is 6. Very similar to the last problem, huh? Looks like we're just finding the other angle, which if we had done the last problem, we could use that information to find this one by doing, 180 minus 90 minus the other angle, but again, that's not necessary. All right, so the relationship between this angle and that side right there is it's adjacent. We know that because it's part of it, and it's not the hypotenuse. We know that because this is the hypotenuse. We're looking for adjacent and hypotenuse. That gives us the cosine function. So we get the cosine of the angle A is equal to the adjacent over the hypotenuse. Just like the last example, We could simplify that to 3/5, but again, I'm wondering why you want to do that. All right, let's move on to the last example that we're going to look at in this video. All right, so we're going to start by drawing a triangle. This one's a little bit smaller than my other triangles. We don't have to draw them gigantic, I guess. All right, so this would be angle A, angle B, and again, just have to make sure that side A is opposite angle A and side B is opposite angle C, and that the hypotenuse is always side C, and that's fine. All right. So now we have that lowercase b is 6, we have lowercase a is 8, and we're looking for capital B. I saw in some other videos that some other YouTube people are calling them little b and big B and little a and big A. I thought I was the only weirdo that did that. So I feel a lot better about calling lowercase letters little and capital letters big, but I've been doing a pretty good job, I think, in this video of keeping that straight. All right, so we don't have this. That's our hypotenuse, so we're going to be using tangent, but just to make sure, that's my adjacent, and this here is my opposite, which, again, opposite over adjacent, that is my tangent function. So I get that the tangent of the angle B is equal to the opposite, which is 6, over the adjacent, which is 8. I know what you're thinking. Can I simplify that? I'll let you answer that question.